In this problem, I'm given the function sine absolute value of x minus 1, and I have to find all values of x for which the function is differentiable. So I'm going to start with a graph. So I have sine, and then I need to get absolute value. And I can go alpha f2 and get my key function, so it's the absolute value function. And I want the absolute value of x, and I close my parentheses. I close the parentheses for my sine function. And now I go minus 1. And I'm going to graph it. Well, first I want to check, make sure I'm in radians. So mode, I'm in radians. So I'm going to go zoom 6. See what it looks like. Well, it looks kind of like a sine function that's been lowered by 1. A little bit of funny stuff going on around there at 0. But I can't really see it that clearly. Thinking about my absolute value function, I know that the absolute value function is got a corner at 0. And that is a non-differentiable spot. Now, I'm not looking at the absolute value function, I'm looking at the sine of the absolute value function. But looking at my graph over here, every place other than 0 looks to be pretty good. I'm guessing that I'm going to have the biggest problem right there at 0 for differentiability. So I'm going to try and zoom in there at 0, and it looks like it's at the point 0, 1. So I'm going to change my window, and I'm going to make my x minimum, and it looks like negative 1. I'll make my x maximum positive 1. And I'll make my my y minimum, I want to go just a little bit above 0, so I'll make it 1. And I'll make my y maximum, my y minimum, I'll make it negative 2, and make my y maximum at 1. And let's see what it looks like now. Well, that to me is looking a little bit like a corner. Not positive. I'm going to try zooming in again. And I'm going to try using the zoom feature. So I'm going to press zoom, and I'm going to zoom in, so I'm going to press 2, and then I'm just going to press enter again. And I'm off the graph, so I can't really see. Well, I could change my window again, and I could go my x minimum, again, I can leave those x minimums there, but it's the y where I'm having trouble. So I could go from the y minimum again from, like, I don't know, let's go like negative, go from negative 2 to 0, see if I can catch it there. Well, again, now I've zoomed in so far, I can't really tell. It almost looks like it's straight. So I'm going to do two things. The first thing I'm going to do is I'm going to go to a better calculator. I'm going to use the Desmos calculator. So I could type in sine, but they also have functions here, just so that you know. There's trig functions, stat functions, miscellaneous functions, including something you'll want to learn in the near future about this derivative function. But I'm going to go back to the trig function. So I want the sine, and I want the sine of the absolute value. So I'm going to go back to my functions, I think. No, absolute value of x, and then I want it to be minus 1. So minus 1. And there's the function. Oh, and in the Desmos calculator, you can see very quickly that I'll try and move it. I'll try and tap it right here. Right there, I have a cusp. That is definitely a non-differentiable cusp. It's much easier to see there. And the rest of it looks smooth and continuous. So that also confirms that. So based on the Desmos calculator, I can see that at x equals 0, I have a cusp. And I could leave it at that, but I guess I'd like to show you another way that I might want to approach it. I have in my calculator the equation that I'm looking at, and it's in the y1 slot of the functions. And I know from looking at the Desmos calculator that it looks very much like I have a cusp that happens kind of like right there at x equals 0. And one of the things about a cusp is you can see that as I'm approaching it, the slope of the tangent line here, well, since it's an upside down cusp, or I'm calling it that, this gets to be an extremely negative slope on this side, so I'm going to write here negative slope. This is this is x equals 0. And over here on the other side of the cusp, it's a very positive slope and then levels off. So over here I have a positive slope. So what I want to do with the calculator is I want to see if I can get the actual derivative, the number, at a number a little bit to this side of x equals 0 and a little bit to that side of x equals 0. And if this number here is negative and this number here is positive, that will be further confirmation that I have a cusp. So the way I do that is this. I go to my calculator and I go alpha f2, and the third function down says n derivative. And that function gives me a derivative of a function at a particular x value. So the first spot is I put in the function. I could type in the whole function, sine absolute value of x minus 1, but since I've already put that in my y1, I can go alpha f4, get all my list of functions right there, and just hit enter on y1, and now that has put my function in that spot. And I put a comma, which is right above the 7, and I'm finding the derivative with respect to x, and I want to find it at a point just this side of x equals 0. So how about if I find it at something like x equals 0.1, and I close my parentheses, and I hit enter, and I get 8. Well, actually, I'm on the wrong side. I did it on this side right here. I did it on the positive side, and I get a positive slope of 0.995, blah, blah, blah. So very close to 1, which makes a lot of sense. Now let's look at it on the other side and see if I get a negative slope. So I'm going to go alpha f2. I want the n derivative function. I want it for my y1, so alpha f4. I hit my y1 right there. I'm getting the derivative with respect to x. And I want it at negative 0.1. And I close my parentheses, and I hit enter. And sure enough, I get the number negative 0.99. So again, I'm getting very good confirmation that I have a cusp, because I have a negative slope of almost 1, and then a positive slope of almost 1 right there at that point, which indicates that it's not this nice smooth curve. So to solve this, we've used the calculator, we've used the graphing program. You could use the graphing program on the TI, you just have to figure out how to zoom in a little bit more accurately. And we also use the fact that we know that the parent function of absolute value of x has a corner.